So here in this problem, we need to prove the following. Let us begin our problem from the left hand side. Here we have cosine of A. So that's multiplied to cosine of 2A. Multiplied to cosine of 4A, but 4 is represented as 2 squared A. Multiplied to cosine of 8A, so that's 2 cubed A. And this goes on to the last one, which is cosine of 2 raised to the power of n minus 1 times A. Now, what we'll do, we'll consider the first function, cosine of A. What we will do, we are going to multiply it with 2 times sine A, such that it becomes 2 times sine A times cosine A. Now, this is an extra term that we are multiplying 2 times sine A, so we'll have to take care of it by dividing it with 2 times sine A. Okay, and the rest of the terms will remain. The reason why we multiplied and divided by 2 sine A, because now this 2 sine A times cosine A is a formula. We know that sine of 2 times A, that's given by sine 2 times sine of angle A times cosine of angle A. Now that means we can replace 2 sine A cosine A with sine 2A, such that we get 1 over 2 times sine A. This will be multiplied to sine 2A, and we have the remaining terms. Now, if we consider sine 2A multiplied to cosine 2A, again what we can do, we can multiply sine 2A cosine 2A with 2, but this is an extra term that we're multiplying, so we will divide by 2, meaning the 2 in the denominator will become 2 squared. So again, we can now apply the same formula, sine 2A equals 2 sine A cosine A, but this time our angle is 2A, which means we are going to get, we have 1 over 2 squared times sine A. So we're going to get sine of 2 times 2A, which means we have 2 squared A. Similarly, this will get multiplied to the rest of the terms. So here we now have sine 2 squared A multiplied to cosine 2 squared A. Again, we'll be multiplying with factor 2, and this means we'll have to multiply a factor 2 into denominator as well. So this 2 squared will become 2 cubed. So now we will have 1 over 2 cubed sine A multiplied to, now what's 2 times sine 2 squared A cosine 2 squared? So that will become sine 2 times 2 squared A. And 2 times 2 squared A, that's nothing but 2 cubed A. So here we have combined 2 sine 2 squared A and cosine 2 squared A, and we have the remaining terms. Like in the previous step, we will again multiply with 2 and divide by 2. So this becomes 1 divided by 2 raised to the power of 4 times sine A, and then combining 2 sine 2 cube A and cosine 2 cube A, that's going to become sine 2 raised to the power of 4A. So this will go on till the last one, which is cosine of 2 raised to the power of n minus 1 times A. So that means now we can generalize it, and we will see that the last will become 1 over 2 raised to the power of n times sine A, and then we will be left with 2 times sine of 2 raised to the power of n minus 1 times A multiplied to cosine of 2 raised to the power of n minus 1 times A. So if we apply the formula, so we have 1 over 2 raised to the power of n times sine A multiplied to sine of 2 times 2 raised to the power of n minus 1 times A. Now, 2 times 2 raised to the power of n minus 1, that's simply going to be 2 raised to the power of n. So that means in the numerator, we get sine 2 raised to the power of n times A divided by 2 raised to the power of n times sine of A. And this is going to be the expression on the right hand side. Thus, we have successfully showed that the left hand side of the given expression equals the right hand side, hence proved.